Okay, class. Good morning. So we're going to move on to the next chapter today, which is chapter 5 in your textbook. So today's exercise is example 5.4, and we're going to get into some network models, which I'll explain in a second. First, let me just talk about the extra credit real quick. That we discussed last time, and I sent you guys an email about the extra credit. Okay, so we didn't finish all of example 4.8 on Tuesday, and so I made the rest of it extra credit, these kind of extension questions. And it's the same questions that we had in the assignment, but I kind of formalized it in a extra credit assignment. So the stuff is right here after example 4.8. If you want, it's extra credit, it's optional. Okay, so if you want to do the extra credit, it'll replace one of the other assignments that you didn't do. So if you have a 0 in any assignments, then you can do this, and replace one of the missed assignments with this extra credit one. And so the questions are here, and it's just basically an extension of example 4.8. So I think we already did one of them in class, but if you want to do that and you have any questions, you can let me know. But turn that in with the other assignments for this week. So if you want to do it, it's due next Tuesday. Okay, and the Excel files you need for that are right here with the extra credit thing. And then like I said in the email, I made a discussion forum for it. Okay, right there. So if you want to do the extra credit, it'll just, again, replace one of the missed assignments. If you've done all the assignments, then you can still do it just in case you miss one in the future, but just note that you cannot get more than 100% on the assignments. So you can still do it if you've done all the assignments for like a backup, but you can't get, once all the assignments are graded, I think there's something like 15 or 20. You can't get more than 100%, so you can do it as like a backup or a missed assignment, but you can't get over 100% on the assignment. So it's kind of up to you. But it goes here. It looks like someone already did it. So if you want to do the extra credit to next Tuesday, and you can let me know if you have any questions. So before we start today's example 5.4, any questions on the extra credit? Okay. Anyway, if you want to do that, that's optional. I'll try to have a few extra credit assignments as we go along, just in case you need to make up missed assignments, but there's one of them. So let's do today's materials example 5.4, which is right here on Blackboard. So you can open up that if you want. And the first Excel file we'll need here is Red Brand Logistics. Alright, so let me read the description for this one, and again, we're going to start talking about some network models. And so this is producing and shipping tomato products at Red Brand. The Red Brand company produces a tomato product at 3 plants. The product can be shipped directly to the company's 2 customers, or it can first be shipped to the company's 2 warehouses and then to the customers. So we'll see the network model there in the figure 317. So nodes 1, 2, and 3 represent the plants. Nodes 4 and 5 represent the warehouses, and then nodes 6 and 7 represent the customers. So we got to meet demand with the product coming from the warehouse in this network. Okay, so we allow the possible shipping of some plants among warehouses and some do not. So if the arrows connecting are double jointed, like there's an arrow at both ends, then you can go both directions. If the arrow just goes one direction, then you can just go that direction. So this is a nice little representation. We haven't really done any network models yet, but the concept is pretty simple. You have an interconnected network trying to model some scenario. Okay, so network modeling is a whole other subtopic, and we're only going to spend a little bit of time on it, but I don't know if you guys are familiar with network models. There's whole classes you can take on network modeling and the like, but we'll just cover the surface and some business model representations of network models. But this is a popular topic that is studied in business. So what this network model here, this picture represents, is the interconnected network. So we have connected, in this network, we have the suppliers. Alright, we have the warehouses if needed, and then we have the customers over here with demand. So everything is connected with this network, and you can see the arrows can flow to and from if it's double arrowed, or if it just goes one direction, you can only flow that direction. So we're trying to use this possible network to get the product to the customer. Okay, so the cost of producing the product is the same to each plant. So Red Brand is concerned only about the shipping costs that we're going to model. The production capacity of each plant in tons per year, and the demand of each customer that we have to meet is in the next figure, and it's also in the spreadsheet. So plant 1 has a capacity of 200, and customer 1 has a demand of 400. Okay, so there's here's the capacity here, 200, and the customer demand is listed over here as demand 1, or demand at node 6 is 400, and demand at node 7 is 180. And so the cost, shipping cost, of a ton of the product between each plant, between the locations is listed in the table. And so we use this information to minimize shipping costs. So let's assume that at most the capacity is 200 tons of product can be shipped between the nodes. So that's like the maximum that'll fit in the truck. And then this is the common arc capacity, meaning that the maximum capacity of each arc of each shipping transmission can only be 200 at most. And so what we want to do here is use all this information, this network, to meet demand in a cost minimization manner, using all the options that we can. Okay, so if we look at the spreadsheet, we'll see how this coincides with the spreadsheet. Okay, so the common arc capacity is 200. That's the most we can possibly ship. And these are all it's already set up kind of nicely where these are all the combinations of networks. All right, so you can ship from origin from node 1 to node 2, and this is the shipping cost 5. And the shipping costs were in hundreds, I think. In thousands. So that would be $5,000 to ship each product. All right, and then all the possible options are over here. So you can ship from node 6 to node 5 to node 6, and the cost is $2,000. And so if there's an option in the network, it's listed. If there's not, it's not listed. And so we're going to choose how much tomato product we want to ship along each network. And we don't have to use all the networks. We're not going to use them all, but we're trying to use the ones that are the least costly first. And the goal here is to minimize cost and meet demand. All right. So let's start going through this. If you go to the Word document. All right. So this is the same thing we just went through. So there's a description of the problem with the network model and the table of the costs. So we already went through that. Our first step, example 5.4, is to just note this is already done. If you were setting up the model, you have to list separately all the origins and destinations, so all the possible routes or nodes. And that's in range A8 to B33. That's already done, but that's here. All right, so this whole range has already set up the possible origins and destination flows and the appropriate cost. So if you were developing a network model, you have to first list all of the network structure, the flows, and the capacity constraints. Okay. All right. Let's just note that our input data is the following things. So it's unit cost, common art capacity, plant capacity, and customer demand. So we can highlight those 4 areas light blue to be inputs. If you go back to the spreadsheet. All right. Common art capacity, V4, that's light blue, that's an input. All the unit costs are set. Those are inputs, so you can highlight C8 to C33. Okay, so this whole area, C8 to C33 are inputs. Highlight that light blue as well. Okay, the plant capacities, those are inputs. So this range, K9 to K11. All right, so at most, plant 1 can produce 200 products, plant 2 can produce 300, and plant 3 can produce 100. So those are the capacities of each plant. And then finally, customer demand, K20 to K21, that's an input. So we got to meet at least 400 of the product at customer 6, so at that destination. And then we got to meet demand of 180 at node 7. So both of those have to be met. Those are inputs. All right. Then let's note what our decision variables are here. So that's all the flows that we can choose or not choose in range D8 to D33. So we'll put any numbers in for now. we'll put zeros in, and then when we run the solver is going to determine the lowest cost solution to get the product to the customer. So D8 to D33. Is our decision variable range, so you can just put, or just highlight that, D8 to D33. All of that is light red for a possible choice. And then let's also put any values in there for now that are going to be chosen or not chosen by the solver later. So let's just put zeros in at the moment. So I'll start in D8 with a 0. And the nice shortcut here is if you just double click the bottom right corner, it'll apply the 0 down, I think. Yeah, there you go. So if you use that shortcut, we're just putting a 0 in all of these red cells. So in D8 to D33, you got zeros and you got that highlighted red, or the light red color for decision variable range. Okay, step 4 is just to link in or sync in the arc capacities, which is in cell B4. So in cell F8, let's just put in equals $B, $4, and then copy it down to reference the arc capacity. All right, so in F8, type in this simple formula equals equals $B, $4, so it should just give you 200. So you're taking the common arc capacity and linking it here, enter. And then if you drag that down to represent all the possible options like this. Okay, so in this whole range, F8 to F33, you should have a 200, and specifically it should say equals $B, $4 to take in the common arc capacity from up here. Okay, so we have let's note we have a big constraint here that we're going to have to meet with the solver. So we know that we can't send more than 200 along each of the flows, along each of the routes. So let's make a constraint inequality here. Alright, so if you want to put a less than or equal to in E8 and just double click the bottom right corner to apply it down for all the other constraints in this range. You got that. So this is what we've done so far. Is we've set up our flow constraint. So in basically D8 to F33. Alright, so we got the flows here with just zeros for now. We have the less than or equal to, and then these should be the arc capacities in this range, which should all say 200. Alright, so everyone doing okay so far? All right, I'll take that as a universal yes for the. Okay, so the next step is to set up the other constraints, which are the node balance constraints. We have to make sure this network is solved evenly. All right, so we're going to have to use this big summary function and put that into cell C19. Sorry, cell I9. Okay, and so let's go back to the spreadsheet. Let's go to cell I9 and put in this formula. Okay, the formula in step 5 it's a big formula, so here it goes, equals. Okay, so I forgot to include the steps to make the range name, so we gotta do that first. Alright, so we're gonna make some range names before we do this step. Okay, so there's a bunch of them, but they're all kind of in a group. So let's make a range name for this whole area. We're gonna make a range name for origin, destination, unit cost, and flow all together. So if you want to select this whole region, which is A7 to D33. Okay, and then let's do our range name process. Click on formulas and then create from selection. All right, and it should say top row, which is correct. So you're going to make 4 range names for origin, destination, unit cost, and flow. All right, so hit OK. You can also select F7 to F33 and make a range name for the arc capacity. Okay, we also need to note that we didn't put in our objectives. So B36 is the objective that we're going to minimize. So you can highlight that cell, the highlight yellow color. All right, and since we've got that, since we're here, let's make a range name for the total cost, the objective. So just select A36 and B36 and do the same process. Formulas, create from selection. All right, and then left column, hit OK. So let's go over to the constraints on the right. All right, so we got a few things to do over here before we type in the formula. So we need to make a range name for all these things over here. So plant net outflow, plant capacity, warehouse net outflow required, customer net inflow, and then customer demand. So first, you can select I-9 to I-11 and make a range name for that. Alright, then K8 to K11, make a range name for that. Okay, then I-14 to I-16, make a range name for that. K14 to K16, make a range name for that. Okay, then I-19 to I-21, you can make a range name for that. And then customer demand in K19 to K21, you can make a range name for that. I think that's our last one. Okay, and let's also put in some constraints here. So we know that the what comes out of the plant can't exceed the capacity, so you can put a less than or equal to in J9 to J11. Okay, the model has to be solved because there has to be nothing in the warehouse in order to minimize cost. So just put an equal sign here in J15 and J16. And the warehouse net outflows are going to be equal. We're going to set them equal to 0. So that'll make sure that nothing is left in the warehouse. So you can just put in zeros in here for now. Okay, in K15 to K16, and then finally, before we start proceeding, let's show that we got a meet demand in this area, so there should be greater than or equal to in J20 and J21.
Professor?
Yes.
Can I see your name, manager?
Oh yeah. So this here. Yeah. So that was the next thing is we made a bunch of range names, so let's confirm that we got these. So we got art capacity, we got customer demand, we got customer net inflow, we got destination flow origin, we got plant capacity, plant net outflow, required total cost, unit cost, and warehouse net outflow. So there's a bunch of range names, but this will make it a lot easier when we type in the formula. So anybody need to go over these range names or do any again?
I think I'm losing something.
Okay. All right. Well, double check the range names. I'll be right back. I'm gonna pour some more coffee in the cup.
Okay, thank you.
Okay. So range names. So we need to go over which ones did we miss?
That's the last one.
The warehouse net outflow. That's just this one. If you select I-14 to I-16 and then you do formulas, create some selection, okay?
Yeah.
Okay. All right, so we got all the range names now, yeah? All right. Well, we'll find out once you start typing in the formulas. But if you don't see a range name referenced in one of the formulas, just let me know and I'll help you redefine it. So, all right. Well, back to step 5. We didn't even start step 5. Okay. You're welcome. So step 5, let's put in this formula. Now that we have the range names into cell I9. Okay, so here's I9 right under the print net outflow. So here's your formula with the range names. All right, so here it is. Equals sum if origin H9 flow minus sum if destination H9 flow. So we're basically saying that whatever comes out of node 1, like the product that comes out of node 1 and the part that goes into node 1 has to come out to no less than 300. Okay, so this is the plant net outflow, which is what comes out of the plant minus what goes into the plant. So this total difference can't exceed the plant capacity. So see how it's doing the like what comes out of the origin minus what goes into the destination for node 1. So that's your formula there. Okay, and if you got that formula, just apply it to node 2 and node 3. Grab the bottom right corner of I9 and drag it down like this. Alright, so that should be the same formula for H10, which is for node 2. And this should be the same formula for H11, which is node 3. See the reference cell? Alright, so we need the same formula in the warehouse constraint outflow area. So if you just copy and paste it and apply it down there, so you can click on the formula at I11 and copy it, Control C, and then just paste it right here. In I15, Control V for paste. Okay, and if you got this far, you can just drag it down one more to get node 5 like this. Okay, so you see that's the same formula for node 4, which is the warehouse, and that's the same formula for node 5, which is the other warehouse. Okay, so did we get that step with the formulas in the plant net outflows and the warehouse net outflows? Alright, so if we got that, the next part is to do the same thing in the customer net inflow, but this is an inflow, so we're gonna put the destination is gonna come first, and we're gonna subtract the origin. So this is net inflow. So same logic, but it's gonna be destination minus origin as opposed to origin minus destination. So in I-20, the formula is equals. Okay, so it's equals sum if destination equals sum if destination H20 flow minus sum if origin H20 flow. So it's the same type of balance constraint, except this time the origin comes second and the destination goes first. So it's what comes out of node 6 minus what goes into node 6. Alright, so you see how node 6 is the H20 reference? And if you got that, you can just drag the bottom right corner and apply it to node 7 like this. Alright, so that should be the same thing for H21, which is cell for node 7. Okay, did we get all those? All the net outflows and net inflows formulas in there? Alright, step 6 is to calculate the objective, which is the total shipping cost that we're trying to minimize. So if you put in this sum product formula in the objective cell B36, that'll set up the rest of the model. Okay, so step 6 in B36 cell, here's your formula equals sum product. Equals sum product, unit cost, comma flow. So this is pretty simple. This is the unit cost for each product we choose to ship, and then whatever number we choose to ship, we got to pay the unit cost. So it's going to be 0 for now because we haven't chosen anything, but each time we ship the product along this route, we're going to multiply it by the cost, and then the sum of all that is the total cost. So make sure it's equals sum product, unit cost, comma flow, and make sure you see that your range names, so unit cost and flow, have been highlighted. So enter. All right, next, and the next step is to solve the model. So we're gonna choose. We're gonna meet customer demand by minimizing cost, or vice versa, minimize costs by meeting customer demand. Okay, let's run the solver. Okay, so data tab and then hit solver. Our objective is the yellow cell, alright, so click on the button and choose B37, B36, sorry. Okay, we're minimizing total cost, so make sure you change this to minimize. Alright, see, we're minimizing total cost, so make sure this is minimized. Now, we're changing the whole flow area. It's a big range, but we know that the range name is just called flow. So I think the easiest thing to do here is just type in the range name. So assuming you have the range name, where it says by changing variable cells, just type in the range name, which is flow. Okay, we're changing flow. If you got that range name correct, it's going to work. Alright, we have a bunch of constraints. So the first one, click on add. Okay, the first one is that flow is got to be less than or equal to the arc capacity. So again, because it's a big range, I think it's easier just to type it in. So if you type in the range name that you have specified, it's just cell references flow. That's less than or equal to the common arc capacity, but less than or equal to the constraint of arc capacity. Okay, so if you have to spell them exactly correct because it's got to match the range name. So if you did the range names, all you have to do is flow is less than or equal to arc underscore capacity. Okay, let's hit OK, see if that works. Okay, so if that works, you should see it there. All right, we have some more constraints, so click on the add button.
Computer showing like must be a number, simple references or similar.
For the constraint?
Yeah.
Okay, so let's see. You can also just select it. So all right. So try doing this for the cell reference. You can choose manually D8 to D33 and select that. And for the constraint, you can choose the range instead. Which is F8 to F33, like that, and then choose that. Okay, so instead of doing the range names, you can also do D8 to D33 is less than or equal to F8 to F33, and see if that works. Is it okay?
Yeah, that's work. Thank you a lot.
Okay, the other constraints, let's click on the add button. So we need to specify these constraints here. So we have plant net outflow is less than or equal to plant capacity. So the cell reference is I9 to I11. And then it'll be less or equal to the constraint of K9 to K11. So there's your first one. I9 to I11 is less than or equal to K9 to K11. Alright, so that's the plant constraint, and hit OK. Alright, and you should see that. Okay, the next one is click on the add button. So the next one is the warehouse constraint. So let's show the cell reference. Okay, and so here it has to sum to 0. So change the little less than or equal to, change that to equals. Okay, so there's our other one. So it should say cell reference I15 to I16 is equal to K15 to K16. So that's the warehouse one. Okay, and hopefully you see that there. And then the last constraint is the demand constraint. Okay, so let's specify that the customer net inflow has got to be greater than or equal to the customer demand. So the cell reference is I20 to I21, and this is greater than or equal to, so flip the sign around. Okay, and then the constraint is K20 to K21. So this one should say I20 to I21 is greater than or equal to K20 to K21. Okay, and so if you got all the range names, you should see the spelled out names there for the constraints. And the last thing before we solve it, I'll double check that we don't need anything repeated, but change the solving method if it's not already to simplex LP. Alright, so let's look at our parameters. We have their objective is total cost. We're met. So that should say minimize. I don't know why. Alright, so make sure we're minimizing total cost. We're changing the flow area, and we have 4 constraints. Customer net inflow is got to be greater than or equal to customer demand. Flow is got to be less than or equal to ARP capacity. Plant net outflow is got to be less than or equal to plant capacity, and warehouse net outflow is got to be equal to required. So make sure that the signs are correct. That's a greater than, that's a less than, that's a less than, and that's an equals. Alright, and then this box is checked. And the solving method is simplex, RP. Okay, so there's a lot to specify. Anybody need any of the solver parameters? I can go over those again if we need those. Okay, well, if we got this, we can solve it and see what happens. Okay, so hopefully you get a solution and you can hit the OK button to see what that solution is. Alright, so I think we should get that, which is 3,260. That's the lowest cost solution. And did we get that?
Professor, I got a different number.
Okay, what did you get?
I got 2,580.
Okay.
And I don't know why. Can I just run through the solver with you real quick?
Yeah. Do you want me to pull my solver up? Or okay.
Yeah, please. I checked it, but I don't know.
Okay. So Dominic, do you want to check your solver, and then if the solver doesn't work, I can look at both of your files.
Yeah, I don't know. Mine says exactly the same thing. And then when you please solve it says keep solver solution, right?
Yeah, exactly.
Yeah, I think I see what I did wrong for mine.
Okay. Yeah. So make sure it's minimized. This is a common problem.
Yeah, mine says minimized too. I don't know why it's 2,580.
Okay.
My flow is different than yours. That's why. I think. Wait.
Well, it's going to have to be different because it's a different solution. So these are just values the solver chose. So maybe I can look at yours if you post it.
On the discussion? Okay.
So post it for example 5.4, and then I'll see if I can look at it. Okay. So so it looks like we have a few people that didn't get 3,260. Do we have did some people get it? Mason got it, yeah? Alright, well, let me just run through the solution that I think we should have gotten. So, you can see that some of the flows are zero because we didn't choose the more costly scenarios. So see how we chose to ship, like the lowest unit costs are the ones we want because they're cheaper, yeah? So we chose to ship 180 along 1 to 3 at a unit cost of 3,000. We chose to ship 120 from 2 to 4 at a unit cost of 1,000. So you see the idea. The ones that we chose, we shipped that number of products in the flow. The ones that are zeros, we didn't choose it, probably because those were too costly. And you can see that the constraints should have been met. Alright, so we didn't use more than we could in the capacities. All the warehouses are empty now. And we met customer demand exactly, which was the goal. So meet demand at the minimum cost of, I think, 3,260. So let me see what some other. Alright, so here's your problem. I think that the warehouse net outflow is not referenced in the right. See how it says H14? It should say H15. See how it's hitting the node instead of the number? So change this.
Change the H15 for both sides. Okay.
This one's probably wrong too. Yeah, this one should be H16 for node 5. Okay, then everything else looks good. So if you try that and run the solver again, see if that works.
Okay. Yeah, it's 3260, right?
Yeah, yep.
Okay, yeah. 3260?
Yeah, that's right. Yep.
Awesome. Thank you so much.
You're welcome. Alright, let me look at the other one here. Okay, yeah, so Dominic, you have the same problem, well, the same area is wrong, but different, so in I-15 it should say equals sum up origin H16. Yeah, it should say H15, and then minus the rest of it, let's change this to H15.
Okay.
Yeah, see that? See how it's getting the right node 4, so in this formula just change the H's to 15. And this one changed the H's to 16, so the same thing I just did with Jessica.
Okay.
See how it's getting the right node, and then let's see if these ones are good. Yeah, so that should do it. Try solving it again and see if that helps.
No, it still said 0.
Yeah, let me try doing it on mine and see if it's the solver thing or it's the... Okay, I think here's one problem. So if you go to your solver, this is the wrong sign. So I know you have to meet demand, so you got to get at least demand, not less than. So if you go to the solver where it says the constraints, subject, customer net inflow, has got to be greater than or equal to demand. So click on that one and change.
To greater than or equal to.
Change it to greater than and hit OK, and then try that again. Yeah,
You got
looks
the
like that.
3,250 that time.
Yeah, that's it.
Okay. Thank you.
Welcome. Well, we have a few more things to do, Trevor, so let's... Okay, so this is, okay, so we're done with the first part. Alright, so we solved the model, we got the least cost solution, which was 3,260. Okay, we'll skip the solver table part because I want to do some other things, so skip this. Let's try doing variation 2, and then we'll do some of the, if we have time, we'll do some of the research questions. So variation 1 with the two products, this one is a little cumbersome, so let's skip this one too. We got about 30 minutes, so let's try doing variation 2, because this one's a little kind of fun. So if you save this one, okay, so the Red Brand Logistics, you can save that, and that's the first file that goes into this exercise, so we're done with this one, and let's go back to the Blackboard page. Okay, if you want to open up the spreadsheet for Red Brand Logistics shrinkage, that's the one we're going to try to do. The one that says multiple products, I don't think we'll have time for that one. Yeah, so just don't worry about that one. But this one we need, open this up. Alright, so this one's done, we did that. You can post that. This one we're not going to do. And this one, let's open up now. Okay, so variation 2 is we have one little thing, and that's the fact that we can, if we leave the product too long in the warehouse, or we can lose some of it, shipping and taking out of the trucks. So there's a possibility, which is normal, for the product to get damaged or spoiled, going in and out of the warehouse, which is common in the business transportation. So we're going to have some of the product is not going to make it out of the warehouse, depending on the shrinkage factor. Okay, so I think it might be quite easier to do this, to start with the original model and just make a few modifications rather than start from scratch, because I don't know if we want to do this whole thing from step one again. So let's close this and open up the other one again. Okay, so sorry about that. Open up the one we just did. So you're back to the one where you got 3260. All right, so let's just go back to this one. Okay, and I think I want to do the one research question for this one, and then we'll do the next one if we have time. So go back to the Word document. Okay, let's do this one real quick. So in the original red van model, which we just did, this is the one we've already solved. Let's assume that the arc capacity isn't constant. So let's modify the original arc capacity. And I don't know if we've used this function before, but it's pretty useful. It's the ran between function. So let's use this, and I'll show you how to use it. So go back to the original spreadsheet that we solved with the solution was 3260. So we got this. Okay, so all we're going to do is change the common arc capacity to be random. So to do that, starting in B8, all right, so just the formulas here or the reference for B4, just delete those. Okay, so the original arc capacity is delete those. And you're going to try putting in random arc capacity, so it's not always 200. So in F8, type in this formula equals ran between, which is a random number between two boundaries. So equals ran between, and let's make it from, I don't know, 100 to 300. All right, so equals ran between 100 comma 300. So it's going to give you a random number somewhere between 100 and 300. Those are the boundaries. And your number is going to be different from mine most likely because it's random, okay? All right, and then you can, if you got the random between function, just apply it down the arc capacity, click on F8 and double click the bottom right corner. And if you did that correctly, you should get a random number between 100 and 300 in this arc capacity range. See how everyone is random?
First number is 203.
Yeah, it's going to be different because it's random. So it's,
Okay.
yeah. So you should get a variation of different numbers somewhere between 100 and 300. Yeah, so they're definitely going to be different because of randomness. So, but as long as the formula says equals ran between 100 and 300, you did it correctly. All right. So did that work? Okay, then since we did that, let's try solving it again. And again, this time everyone's going to get a different solution because you have random numbers in the arc capacities. So run Mixsolver again, hit solve. And you're going to get a totally different number here than mine because your arc capacities are now random. So the ones that have, it's a crapshoot if you get more capacities on a cheaper route, then your total cost will be lower. But you're going to get some random, not some random solution, but some total cost that's different than mine if you did this based on the randomness in the arc capacity. Yeah? So we probably got something a little bit different than what I got, but somewhere in the range of, 2,000 to 3,000 most likely. Alright, so did we get that to work there? Did we get some, again, your solution will be different than mine, but it should have been able to solve with the random arc capacities. Yeah? Okay, let's now try doing the other variation real quick, and then that'll be the last thing. So let's go back to the Word document. Okay, so now let's try doing this one. So all we're going to do is modify the original model to incorporate the fact that there's shrinkage, meaning that some of the product can be spoiled in the warehouse. Okay, so we need to add one little row here underneath the, what is this? Actually, let's just type it in. Or let's, in A5, type in shrinkage factor right there. Okay, so this will be the percent of the product that makes it out of the warehouse. So, let's start with 90% in D5. And that's now going to be an input, so you can color that light blue. Okay, so right here you have the shrinkage factor, and then right here you have 90%. And again, this is defined as the portion of the product that makes it out of the warehouse. So 90% on average makes it out. The other 10% gets lost or spoiled when we put it in the warehouse. All right, and also let's reset our capacity back to 200, so we get the same solution, hopefully. So replace your rand in between back to the original, just what is this? F8, this is equal to. $B, $4 for the 200 arc capacity, and hit enter. And then just apply that down back to what it used to be. So all the arc capacities should be reset to 200. Okay, and let's make one modification over here in the constraints, and then we'll run the solver again. So you need to put this formula in Okay, so put that formula in I-16, and then we'll run the solver again. Sorry, I guess it should be I-15, so this is equal to. So in cell I-15, we're modifying the formula to incorporate the shrinkage loss possibility, so equals. Alright, so here's your formula that goes into cell I-15, so it's equals sum if origin H15 flow minus $B$5, so that's the percent that makes it out, times sum if destination H15 flow. So really the only thing we did was put this in there. Okay, so you can do the same for the next one. So I guess it would have been easier just to put in the percent spoiled. So in I-16, just put a $B, $5 times here. Okay, so let me go over what we did. These are the only changes we did to the model. Alright, so we put the shrinkage factor here, and it's the title shrinkage factor in A5, and in B5 it's just 90%. Okay? We changed the original R capacity back to 200 for all of them. And then your only modified formulas in I-15 and I-16 should be these, where you just basically put the $B, $5 in front of the outflow. Okay, so this one should say equals sum if origin H15 flow time minus $B, $5 times sum if destination H15 flow, and then this one should say the same with the H16. This one should be equal sum if origin H16 flow minus $B, $5 times sum if destination H15 flow. Okay, so we just added those shrinkage factor percentages in front of the destination part, and that was really the only change.
Mine is a little bit different, but is it okay? I don't know why it's different, but it's a little different.
It doesn't say 23.4 and 29.
It says the first one is like way off. It's like 16.7, and the second one is 29. And I looked at it, and it's the same.
Yeah, that's because the flows are from the last solution. So if it's different after we solve it, then something's wrong. But
okay,
the flows are based on the randomness from last time. So yeah, as long as the flows are good, yeah.
From the random flow that we put, or the capacity.
Yeah, because the flows are still set to whatever.
Still what it was? Okay.
But do make sure that these are now 200. Yeah.
Yeah, they are. Okay, thank you.
Okay. All right. So let's, if we got that so we didn't do much, but if we got that modification, let's solve it again and see what we get. So we should get a little bit higher cost because some of the product has been lost in the warehouse. All right, that's the new concept here. So all you have to do is rerun the solver. Okay, hit solve and hit OK. And I think the new higher solution with the fact that we lose some in the warehouse should be 4,890. All right, do we get that? Oh, great. Okay, so everybody got the solution. So what we did, all we did was incorporate the fact that 10% is lost, and it's easy to modify this model if you, like, this is the shrinkage factor, so anything, like this means that 10% of it is lost. If it was 80%, that would mean that 20% is lost and so on, so it's easy to modify once you set it up. And yeah, so we chose to ship these many products along the cheapest routes as possible. And we didn't go over our art capacity. We produced exactly what was allowed in the plant. You can see that there's nothing left in the warehouse, and we met demand. So the reason why it was more costly this time is because you have to pay for some of that 10% of the product, which is lost along the way if you use the warehouse. Okay? All right, so I think that's enough for this one. So you can save this. And that can go into the example 5.4 discussion form. Okay, so that goes in there by next Tuesday. And if you just got through the original part, then that's fine. If you modified it to now include the shrinkage factor, then just put that. So I know we modified the same one. So just put the final one you have, and that's fine. So the one you post should either say, okay, so it should either say 4,890 for the shrinkage factor, or it could be the random one from the random arcs, or the original solution was 3,260. So just the point is just post whichever final one you have, just post that. That's good, and I think that's it. So that's going to be it for today. And these two exercises. Okay, so next Tuesday, example 4H2. If you want to do the extra credit, that's due next Tuesday. And also the one we just did, example 5.4 is due. So these two, and then if you want to do the extra credit, that's due next Tuesday. All right, and we'll do some more next Tuesday, but that's it for the week. And everyone, please have a good weekend and stay safe. And I'll see you on Tuesday morning.
Thank you.
Good.